Hello, my name is Jacob Boone, and I worked with Dr. Liao on this research project funded by the West Virginia Higher Education Policy Commission Division of Science and the Research SURE grant program. The purpose of this project was to develop a portable face mask detection and temperature reading device that detected if a person was wearing a face mask and their temperature was within a certain range. A Raspberry Pi, a video camera, and an MLX 90614 infrared sensor were used. A convolutional neural network MobileNet v2 model using the TensorFlow Keras library was trained on approximately 500 photos of people wearing and not wearing masks. The model is saved as a readable file and can be sent to a Raspberry Pi for use. This allows the training of the MobileNet v2 to be on a separate computer and then uploaded to the Raspberry Pi. The training program on my computer, for instance, took close to 2.5 hours. I tested and could not get the training program to finish within 6 hours on the Pi. The accuracy of the detection program on the training data is closer to 98%, and the accuracy of the validation or testing data is close to 95%. The detection program captures frames of a video stream from a connected camera and inputs it through the MobileNet v2 model. The model then predicts whether a person is detected and if they are or are not wearing a mask. A MLX 90614 infrared sensor was interfaced with a Raspberry Pi and used to detect the temperature of an object within its field of view. The operating distance of this specific IR sensor is 2 centimeters to 5 centimeters. The detection program uses the Python library SMBus2 and the locally stored Python library folder MLX 90614 to read the object temperature from the IR sensor. Then the Celsius temperature is converted to Fahrenheit for use. If the red temperature is within the programmed range and the MobileNet v2 model predicts that the person is wearing a mask, then there is a green box displayed around the person's face. If the detected temperature is out of the range or the model predicts the person is not wearing a mask, then there is a red box outlining the person's face. Having the Raspberry Pi capture images and run them through the neural network is beneficial, but the information was isolated on the Raspberry Pi and is not being shared with another system. Creating a client-server connection would allow the installation of the client program on the Raspberry Pi to be separate than the server program, therefore allowing a person to view the results of the detection of a face mask and temperature reading from a safe distance or even from a completely different part of a building. A client and server program were written to allow the MobileNet v2 neural network detection program to be utilized outside of the Raspberry Pi 4. The client program on the Pi 4 captures a frame of a video stream and reads an object temperature with the IR sensor and sends the object temperature, Raspberry Pi 4's name, and a compressed JPEG of the frame over a socket connection created by the Image ZMQ library. Image ZMQ was designed specifically to help send images and a message over a socket connection. The connection established between the server program and the client program is a request-reply format, which means that no new message can be sent by the client unless the server sends a reply message stating it received and processed the current image. The server program decompresses the JPEG frame and sends it through the MobileNet v2 neural network and displays whether the detected person is wearing a mask and if they have a normal temperature or not, and sends a reply message after the image has been predicted and displayed. The request-reply format prevents the client sending images faster than the server can process them. Thank you for listening to my presentation about face mask and temperature detection on a Raspberry Pi 4.